And for watching Learn Something with Pavitro. So today our topic is object oriented analysis and design using UML. So for that we have the first unit 1, which is introduction to UML. Introduction to UML. So we will discuss this topic today. So first we will today discuss this topic. So for that, let's check our live video is going properly or not. So for that, okay, that's work properly. So let's start. Importance. First topic in unit 1 is importance of modeling. So uh, the real life example of importance of modeling is building a house. Okay, building a house. Before construction begins, an architect creates a blueprint, a model of the house. This model helps visualize the final product, identify potential issues early on, and ensures everyone involved, architect, builders, constructors, is on the same page. Means before creating a such a real life product or thing, we need to first of all create a visualization of their product or that thing. So this is called UML, and for this is called design, and for creating this design we use the UML for creating this design. So for better visualization and create a better product or thing. Okay, so now benefits of modeling. What is the benefits of modeling? So first of all, improved communication. Means models provide a common language for stakeholders with different technologies backgrounds to understand the system. Okay, then early detection of issues means identifying and resolving problems in the model is often easier and cheaper than fixing them in the final product. Then documentation. Documentation means models serve as a reference throughout the development process and future maintenance. Okay, so let's discuss some questions of this topic, which are how can modeling benefit the development of a new software application. Okay, then second question, what are some challenges associated with creating effective models? So let's see the answers of these questions. Let's wait for the answer. So let's see what are the answers. Okay, let it go. Go to the next topic. Next topic. Okay, let's move on the next topic. Okay, principles of modeling. So what are the principles of modeling, or what is the principle of modeling? So let's take a real life example, which is, imagine you are baking a cake. Okay, we are baking a cake. Okay, you would not just throw random ingredients together and hope for the best. Instead, you follow a recipe which is essentially a set of established principles for achieving a desired outcome, a delicious cake. Okay. Similarly, in software development, principles guide the creation of effective models. Means parsimony, means Os Osam's razor. Okay. Keep it simple. Models should capture the essential aspects of the system while avoiding unnecessary complexity. Then focus. Clearly define the purpose of the model and tailor it to that specific goal. Accuracy. Models should accurately reflect the intended system and its behavior. Clarity. Models should be clear and easy to understand for all stakeholders involved. Okay, so what are the questions here? How can the parsimony principles be applied in creating a UML model? Okay, why is it important for models to be accurate? So I don't here answers. Okay, that's okay. The goal is to understand these principles, not necessarily know the specific answers to every question at first. Share some additional information to help you think about the questions. Okay, parsimony, questions, and UML model. Imagine a UML model for a shopping cart system. Okay, imagine a UML model for a shopping cart system. Okay, it might include classes for product, shopping cart, and customer. However, adding unnecessarily complex elements like detailed animations for adding items to the cart would not be following the parsimony principle. Focus on capturing the core functionality in a clear way. Okay, then accuracy in models. Okay, so an inaccurate model could lead to misunderstandings and mistakes during the development process. For example, a UML model that incorrectly request represents the interactions between different system components could result in errors during coding or testing. Okay, let's move on the next topic. Okay, let's see the answers with the next topic. Some guidance and explanation, it's important for you to actively the learning process. and try to answer the questions yourself. This focuses a deeper understanding of the concept, helps you retain the information better. Okay, however, the answers of the questions from the previous topic, principles of modeling. Okay, how can the primary parsimony principle be applied in creating a UML model? By focusing on the essential elements of the system and its behavior, avoiding unnecessary complexity in the model itself. This means including only the classes, attributes, relationships, and interactions that are crucial for understanding and designing the system. For example, in a simple library management system, a UML class diagram might only show classes like book, author, and borrower, along with their essential attributes like title, author name, and borrower ID. It would not need to include detailed information about book, cover, images, or user interface elements, as those are not part of the core functionality. Why is it important to important for models to be accurate? Okay, accuracy ensures that the model faithfully reflects the intended system. This is crucial for several reasons, such as effective communication. An accurate model allows all stakeholders mean developers, designers, testers, etc., to have a common understanding of the system, avoiding misunderstanding and misinterpretation. Okay, early problem detection. Inaccuracies in the model can lead to flaws flaws in the final product. Identifying and fixing these issues early in the designing phase, when changes are easier to make it much more efficient than finding and resolving them later in the development process. Okay, then predictability. An accurate model helps predict the behavior and performance of the system, allowing for better planning and resource allocation during development. Okay, then remember, the goal is to not just memorize these answers but to understand the reasoning behind them. Okay, let's go to the next topic. What is the next topic? Let's see. So unit 1 is topic 3, object oriented modeling. So real life example. Imagine a car manufacturing company. They would not build every car from scratch using entirely unique parts of each vehicles. Instead, they design and manufacture various car parts in like engine, wheels, streets, okay, that can be combined in different ways to create different car models such as sedan, SUV, truck. Okay, this is similar to object-oriented modeling where we identify real-world entities, mean objects and their relationships, then define classes as blueprint for creating objects with specific attributes and behaviors, then utilize inheritance to create specialized classes, subclasses that inherit properties from more general classes, superclasses. Okay, then benefit of object oriented modeling. So first benefit is reusability. Reusability means by using classes and inheritance, we can reuse code and avoid redundancy. Then modularity. Modularity means breaking down the system into well defined objects, promotes modularity and modularity and easier maintenance. Then encapsulation. Encapsulation means objects encapsulate data and behavior, promoting data integrity and security. Then let's go to the next topic. We don't need to discuss now at the time answers. So the next topic is conceptual model of the UML. Conceptual model of the UML. The UML means unified modeling language for creating models of a product or object, that is called Unified Modeling Language or UML. Provides a set of building blocks and diagrams to visualize and document software systems. These building blocks include things, relationships, and diagrams. So things means classes, represent blueprint for creating objects, interfaces, define contracts that specify what functionalities objects must provide. Then packages group related elements together for better organization. Then relationship, okay, in relationships, associations. Association means connections between objects. Then generalizations means inheritance. So relationships where one class inherits properties from another. Then dependencies. Dependencies means one element relies on another or dependent on another. Okay. Then diagrams. Diagrams means different UML diagrams represents aspects of the system. Okay. Then class diagram shows classes, attributes, methods, and relationships. Then use case diagram, what it will do, depicts actors and their interactions with the system. Okay. Then sequence diagram means illustrates the sequence of messages exchanged between objects in a specific scenario. Then go to the next topic. Software development life cycle is the last topic. Okay. Covered conceptual model of the UML. Conceptual model of the UML. Architecture, software development lifecycle. Mm, we have covered the first three topics of Unit 1. Let me know if you like to revisit any of the topic. Next topic, architecture. Next, let's go to the architecture. Okay. Architecture, real life example. Imagine building a house. The architect does not have just start constructing walls without a plan. Okay, they design the overall architecture which defines foundation. Foundation means the fundamental concepts and technologies that supports the entire system. Then structure, the high level organization of the system including its major components and their interactions. Then behavior means how the system responds to external stimuli stimuli okay, and interacts with its environment. Then similarly, software architecture serves as a high level blueprint for a software system, outlining its components mean major building blocks of the system, like user interface, database, service layer, okay, then connectors, how components interact and communicate with each other. Then constraints. Constraints means rules and limitations that guide the system's development and operation. Then benefits of software architecture. First is improved maintainability and scalability. A well-defined architecture allows for easier modifications and adaptation adaptation or to future needs. Then the next, reduce complexity, means by breaking down the system into manageable components, complexity is controlled. Then enhanced communication and collaboration. A clear architecture fosters better understanding and communication among developers. So now let's go to the next topic, which is software development life cycle, means SDLC. Software development life cycle, SDLC. The SDLC is a framework. The SDLC is a framework outlining the phases involved in the development of a software system. It provides a structured approach to ensure quality. Quality means meeting the desired functionality and performance requirements. Okay, then efficiency, completing the project within budget and time constraints. Then maintainability means building a system that can be easily modified and updated in the future. Then types of SDLC phases. Okay, so first, planning and requirement analysis, means defining the project scope, objectives and functionalities. Then design. Design means creating a blueprint for the system's architecture, components and interfaces. Then development means coding and implementing the system based on the design. Then testing, evaluating the system for functionality, usability and performance. Okay, then deployment means releasing the system to its end users. Then maintenance means fixing bugs, adding new features and keeping the system operational. Okay, benefits of using SDLC. Benefits of using SDLC. So first benefit is reduced risk of project failure, means by following a structured process, potential issues can be identified and addressed early on. Okay, then improved communication and collaboration, means the SDLC fosters better communication among stakeholders involved in the development process. Okay, then clearer project milestones and deliverables, means each phases phase has specific goals and outcomes, leading to a more predictable development process. Okay, so I think we cover all the topics of unit 1. You can see here unit 1. In the unit 1, last topic is software development life cycle. So we cover also the software development life cycle. So we will be back or come with the next unit, which is unit 2. So for that, that's all of the video, end of the video. So for that, stay healthy and stay safe. Thank you for watching the